Welcome to AWS in 1 hour. My name is Noah Gift, and I'm the author of Python for DevOps, Pragmatic AI, and also an upcoming book, Practical MLOps. I wanted to cover what AWS is in a nutshell for people that might not be familiar with AWS, and also get into some of the hands-on details of AWS so that you can feel in just a short amount of time powerful enough to, get into the console, do things, and talk to other people in your company about AWS. So this video is really a short rundown of what AWS is, and it should give you enough to get started. And there's other videos I've created that I'd recommend you take a look at if you want to get a little bit deeper into the AWS technology. Let's dive into the topics that will give you a firm grasp of AWS in an hour. First, there's the cloud. We're going to talk about what the cloud is in a nutshell, and what are the core concepts that you need to be aware of. We'll also get into the economics of the cloud. What are some of the core principles that make cloud computing so compelling? We'll also get into compute. So what are the compute components of cloud computing? We'll also talk about storage, things like a data lake you may have heard of. We'll get into that. Databases, there's several different types of databases in cloud computing, and we'll talk about the pros and cons of all those. We'll also talk through some of the architecture of AWS and why it's a huge advantage for people that use cloud computing. We'll talk about some of the huge advantages as well of security in the cloud and how there's a shared security model. We'll get into things in networking, including VPCs, which are virtual private data centers, and we'll talk about how those capabilities can help your company. We'll also talk through the global infrastructure of cloud computing and why there's some huge advantages as well to using a global infrastructure that you didn't build yourself. And then we'll finally talk through autoscale and how autoscale can help you build robust applications. These are some of the key AWS cloud concepts to be aware of, and you'll hear these terms if you ever want to go into AWS certification. First, the cloud is on demand. So this is one of the core capabilities of cloud computing. It's a lot like a utility company. So if you want to get gas to power your house or electricity to be turned on, that's really the same concept as cloud computing. It's probably the most fundamental concept to be aware of. Also, this infinity symbol here, I think, is really critical to understanding cloud computing. What it means is that there is near infinite capability for you to use compute, to use storage, to use networking. And so this capability also gives you things that really is not a core capability of a company that builds their own data center. If you're building a data center yourself, you're not going to be able to spin up millions of dollars of servers and then build a global infrastructure easily. It could take, let's say, 10 years to get that capability. But from day one with AWS, you have this infinite capability. Also, with AWS Cloud Computing, there's infrastructure as a service. And one way I like to describe this is think about the different ways that you can get food. You can go to Costco and you can get a 50-pound bag of flour, or you could go to a restaurant and you could get a burrito, or you could go to the grocery store. It's very similar to that in that infrastructure as a service saves you a lot of money because you can buy things in bulk. And that's really the core concept of infrastructure as a service is you get to use AWS's buying power to get things for a lower price. Let's also talk through the service model, which is another topic that comes up a lot in cloud computing. And really there is IaaS, which is infrastructure as a service. There's also PaaS, which is platform as a service. And there's also SaaS, which is software as a service. And these three terms, if you're an executive in a company, you should be aware of these terms because really they decide what part of the cloud computing infrastructure you're going to participate with. If you're doing something with, let's say, Google Docs, you're using software as a service. If you're deploying a new application for your organization, you may be using a platform as a service offering, and that could be on AWS, something called Elastic Beanstalk. If you're using the core virtual machine technology, then you're using infrastructure as a service. Finally, let's talk through economies of scale. Economies of scale, this concept is a lot, again, like a utility company, where because you're able to use just what you need, you're able to trade that cost of the upfront cost of millions of dollars of building your own virtual data centers and instead use the economies of scale and the buying power of AWS. So these are really the core characteristics of cloud computing. If you understand these core characteristics, you'll understand AWS. Let's talk through some of the core cost drivers of AWS. If you're going to use AWS, this is maybe one of the first things that you're going to have to talk through. First, there's compute. So what compute means is that you're charged per hour or second, and it also varies by the type of instance you spin up. So if you spin up a large 100-core machine, it'll be charged more than a single core machine. Also storage, you're typically charged by the gigabyte when you're using storage, and that's a core cost driver to be aware of. Data transfer, what this means is that when you're dealing with data, the outbound is aggregated and charged, and the inbound has no charge. So really putting data into AWS, there's no charge for it. But if you're going to go back and forth, you're going to need to walk through that cost scenario. And you're also typically charged by gigabyte as well. So what are some of the core concepts in paying for things on AWS? Well, one of the things that's important to be aware of is that you pay for what you use. And this is a lot, again, like a utility company. And so this allows you to be efficient in using AWS. Also, you pay less if you reserve up front. So it's a lot like you can save money on an airline flight to Europe by going a year in advance and reserving that ticket. It's the same concept with AWS. And then finally, you pay less when you use it in bulk. And so the more you use the services of AWS, the cost goes down because you're able to use things at a cost-efficient pricing structure. So really, in a nutshell, these are the core drivers of AWS. And if you're aware of these core drivers, you'll be able to be efficient with using pricing on AWS. AWS Global Infrastructure is the core undertaking of AWS. Really, this is the road that leads to AWS, and it's the pieces that make you able to use cloud computing. Let's talk through three key terms that if you understand these three key terms, you'll understand the global infrastructure. A region, you'll hear this a lot with AWS and you'll say, what is a region? What does this mean? Well, it's a geographic area of AWS. So this could be in a globe here, you could have, for example, North America, you could have the East Coast, you could have the West Coast. These are geographic areas. Maybe in Europe, you have a region. Also in South America, you can have a region. These regions live on a global basis, and you can choose which region you want to work in. Inside of the region, there's always multiple availability zones. And these availability zones are isolated. And what this does is allows you to build an architecture that, let's say, has 3 availability zones. We'll call these AZs. In, let's say, the East Coast of the United States. And why is this important? This allows you to have redundancy. So again, region is a geographic region. Each region has multiple availability zones, and typically a world-class architecture would build across multiple of these zones so that there's redundancy in case there's a problem in a particular zone. Now, what's inside of this availability zone? So inside of an availability zone is one or more data centers. And so a data center is somewhat intuitive. It's 50 to 80,000 servers. And so if you look at one of these availability zones here, you can see that inside of it's a data center, and that's where all the work is being done. And you could have one or more data centers inside this availability zone. And if there's a problem with this physical data center here, what will happen is if you're using a multiple AZ infrastructure, it'll transparently be able to use the other resources in the other availability zone, let's say a database. And so that's really the core concept here is redundancy is built into the architecture, and it's in the form of region, availability zone, and data center. AWS Security is full of lots of surprises. And one of the surprises is that many times you'll think that the cloud is less secure because it's opaque and it's up there somewhere, but it's actually much more secure than a typical company implementing security. And the core reason for this is this shared security model or a shared responsibility model. And what this is it's intuitively something that makes a lot of sense. If there's an expert, for example, that builds your house, if you're not a house builder, you're leveraging those capabilities to build a foundation that doesn't fall down. The same thing goes with AWS is there's a foundation around AWS where you don't have to build the core infrastructure yourself. you're leveraging the talents of those AWS customers. And so in a nutshell here, as the customer, you're responsible for the data itself that your application brings in. In AWS, they're responsible for the hardware as well as the software. And so this is really why AWS Security is something that gives you a lot of comfort in that on your end, you just need to make sure that the business logic is successful, that you're encrypting data at rest, that you're doing best practices, and then AWS handles things like deciding who can get into the data centers. That's something that goes away now. You don't have to manage keycard access or manage patches on physical hardware. There are experts that are really world-class experts, and they're managing that infrastructure. Let's talk through the AWS network. Really, you can understand AWS networking in just this one diagram. The cloud itself is on the outside here, right? So this is every piece of the global infrastructure. And inside of it, you have regions. We discussed this earlier, how there are regions all over the world. And inside of a region, you have multiple availability zones. And you can see here, this would be AZ1, availability zone 1, AZ2, availability zone 2. And each of those would have a subnet. And a subnet is where the network traffic would talk to each other. Overlaying both of those availability zones is this concept of a VPC. And really, a VPC is probably the most important networking concept to be aware of. It stands for Virtual Private Cloud, and it's logically isolated from other VPCs. So what happens is that you can make sure that the traffic only occurs in this virtualized sense inside of this one VPC. So if something's in a different region, you wouldn't be able to talk to it without doing some kind of networking operation. It's dedicated to your account, and it also belongs to a single AWS region. But as we can see here, it spans multiple availability zones. And a subnet is a range of IP addresses that divides a VPC, and it belongs to a single availability zone. So this is a core concept here, is that notice that there's a boundary line here on a subnet. A subnet belongs to an availability zone. And these subnets can be classified as either public or private. So if you understand those core concepts, when you hear a VPC or you hear an AZ or you hear a subnet, this is the slide that you can go to and make sure that your understanding is mapped to the direct diagram. And in particular, if you look at the AWS cloud, that's really the building blocks of all networking in the AWS cloud. AWS Compute is really one of the core services of cloud computing, right? You really want to do something with a computer like your laptop or a physical desktop. And in the cloud, you're going to be doing things in a virtualized manner somewhere. The good news is that to understand AWS Compute, you really need to understand these 4 blocks here. So we've got the first block, which is EC2. We've got the second block, which is Lambda. We've got the third block, which are these things I'll talk about in a second. And then you've got this elastic beanstalk. So let's go through here and describe what each one of them is. So EC2 is a virtual machine technology. So it's a lot like VMware or some other virtualization technology like Parallels that you may have seen in the past. You can spin up a Windows machine, you can spin up an OS X machine now, you can spin up a Linux machine, and you can run some workload on them. So really that's the core capability of EC2, and you can spin up anything from a dual core machine all the way up to a 100 core machine with a terabyte of RAM. AWS Lambda is a little bit different in that it's really a piece of code that's mapped to logic in the cloud, and it's event driven. And what's interesting about AWS Lambda is that you can quickly build services by mapping them into a piece of code that's, let's say, 5 lines long, and then you can respond to an event. And so it's a very high level way of programming, and we'll get into that at the end of this video, and I'll show you how quickly you can build code with AWS Lambda. This third block here is all about containers. And so you may have heard the word Docker before. If you haven't, Docker is a container format. And you also may have heard the word Kubernetes before. Well, Kubernetes is the ability of a orchestration system to orchestrate containers. And containers are similar to virtual machines, but the big difference is they're more lightweight. They can spin up more quickly, but they need some kind of an orchestration layer. So they actually allow you to put the runtime of the code inside with the code itself. And that's really one of the core advantages. So Amazon has ECS, which stands for Elastic Container Service. They have EKS, which is Elastic Kubernetes Service. They have Fargate, which is a way of spinning up one container on demand, and then ECR, which is their Elastic Container Registry. So in a nutshell, the high-level overview is that if you're dealing with containers on AWS, there's many different solutions for them, and in particular, you'll have to check one in to the container registry, and then you can choose which of these different execution environments to run from. It could be Fargate, which is a single use case. It could be EKS, which is Kubernetes as a service, or you could use ECS, which is their own orchestration layer. Finally, that leaves us with Elastic Beanstalk. And what is Elastic Beanstalk? It's a PaaS, or a platform as a service. And the advantages over, let's say, just using EC2 is that you can build something. Let's say you're using a web framework like Python Flask. You can take this Flask application, put it onto a Beanstalk, and then you don't have to worry about physically provisioning machines and installing software. All that's handled and managed by the experts at AWS. So there's some really key advantages in using something like a PaaS to develop your application. So if you're an executive in a company, if you had to choose between these services, really in terms of the expert level, EC2 would be where you'd have to have a lot of expert developers in your company. If you wanted to have something that's more hands-off, you would probably use something like either AWS Lambda or the PaaS Elastic Beanstalk, because it allows your developers to move more quickly and you have to have less expertise in your organization. Let's dive into AWS Storage. There are 4 key components of AWS Storage that you'll run across. And really, what's simple about it is if you're talking about a virtual machine, you're going to be using some form of elastic block storage to share your data to an application. And it's important to know that this particular storage is a one-to-one. So you can take this storage, you can expand it and make it grow to a very large size like terabytes, but it has to map physically to an EC2 virtual instance. Now there's some things you can do with it, like you can detach it and you could snapshot it and make copies of it, but everything is a one-to-one ratio. One of the nice things about elastic block storage though is that you can provision it and make it have IOPS on demand. So you can make it have a very high performance storage mechanism and actually attach it to your EC2 instance. The next form of storage here is S3, and this is object level storage. And the best way to think about this is it's a giant data lake. And if you want to store, let's say, petabytes of data, this is the place that you'd want to put it. And in fact, it's got 11 nines of reliability. What that means is that it's 99.99999, and I won't repeat all the nines here, of reliable. And so it's essentially never goes down, or if it does go down, it's a couple milliseconds a year, because it's got so many different copies of the data. So if you have large data that needs to be warehoused somewhere and it's object level, like an image or a video or a file, this is the place that you would put that storage. Next up here is a elastic file system, or EFS, and EFS allows you to do shared storage across a cluster of machines. What's really fascinating about something like EFS is it's been around for a long time, a network file system, but with the cloud, it allows you to, let's say, have 1,000 different machines attached to this shared storage device, do some work, and then go away, but that storage is still persistent and it's managed by the AWS team. Finally, we have offsite storage, which is Glacier, and that allows you to take things that are in, let's say, S3 and have some kind of a policy where they're automatically archived so that if there is a disaster, you can restore from that Glacier backup. AWS has a wide variety of databases. A lot of times when you say database, most people think about a relational database, but a relational database was really thought up in 1970. And since then, we've made a lot of advances, and there's many different kinds of databases. A relational database is often good for, let's say, transactional operations, but there are other databases that are good for different types of operations. So in the case of a key value database, we have DynamoDB, And Dynamo is a key value database that a lot of companies are using to store things like social media data or game data, and allows you to have a trade-off where you don't necessarily need transactions, but you want something to be eventually consistent. So in a nutshell, what that means is if you refresh a web page, eventually you'll get the data, but it's not important if it's slightly inconsistent for a few milliseconds. A document database is similar, where if you have things that are stored more as a document, a DynamoDB database could be a good solution. Also graph databases, with all of the rise of social media and these different social applications, many times a graph database is a better fit for that model, where if you're doing things where you want to do queries across different databases, it's really cumbersome. But with a graph database, you can directly talk as a group of people would talk. Now, in-memory databases are another solution here, and the best way to think about this is a cache. So if you need something to be constantly accessed, but maybe not updated that often, a cache could be a good solution for you. And you can use those cache databases inside of the AWS ecosystem. Finally, there's a search database. And with search here, what's neat about it is that you can use the leverage the technologies that are available from the experts in AWS to do a search database like Elasticsearch, and you don't have to manage the underlying infrastructure. So there's lots of different databases, and most companies that are adopting the cloud use more than one database, and this is really important to know about. When you're developing something on AWS, or you're certified, or your company is certified on AWS, you have to go through the framework of the best practices of how to develop something on AWS. And let's go through those best practices for a well-architected architecture. So in this case, we have secure. So you need to make sure that you're doing things according to the shared security model, where you're protecting the customer data, but you're relying on AWS to handle the physical infrastructure. So that's a core component of a secure framework. And it also incorporates things like encryption at rest and encryption at transit. And you're aware of those different concepts, and you're making sure that you're following those best practices. Also, high performance, are you building things that are scalable and elastic, and are they able to perform according to the customer's needs? Another one is resiliency. So AWS has this shared architecture where there are regions all over the world. There's also multiple availability zones, and there's multiple data centers. And are you architecting your application to be resilient in the face of something that's easily preventable? And so if you're developing things according to the way AWS recommends it, you'll make a resilient application. And then finally, efficiency is a core component as well, is that you shouldn't be using, let's say, 100 core machine to do something that only a 2 core machine would use. And so this is really about using only what you need and not wasting resources. And that's a core component of the AWS infrastructure, is really doing the best that you can and being as efficient as you can, and that's a well-architected framework. Another key component of the AWS cloud is this concept of load balance, load balance here, and monitoring. And in both situations, what you're going to do is think about the architecture and the workflow of an application. So let's take you have these customers here that are using, let's say, your sports application that gives people updates on scores. Well, they're talking to the application, and it's getting busier and busier. So how do you handle this? Well, you can have elastic load balancing that will talk to whatever compute resource you're using. It could be EC2, it could be containers, it could be Lambda, and it'll scale up according to the demand automatically. And this is really probably the most fundamental concept of cloud computing, is that you're able to scale up and down according to the demands that your customers put upon your application. And so that's what load balancing is the ability to respond and spin up these additional compute resources that will meet the needs of the customer. Another core component that's related to load balancing on AWS is CloudWatch, and you'll hear this a lot. And CloudWatch does a lot of different things, but in particular, it monitors applications. So it looks at CPU, memory, health metrics, and that monitoring data can go into the load balancing, and you can use that monitoring data to spin up a new machine. So how would you do this in practice? Well, if there's, let's say, 75% of the CPU on an EC2 instance is been hit, then you could tell the CloudWatch machine to service to actually spin up another EC2 instance. So that's really the mapping of those two services. It also tracks data, so you can go through and you can search across events. You can set alarms, and those alarms again can trigger things like spinning up a new EC2 instance. And also you can look at events. So if there's maybe a scheduled event that you want to run, you can actually run that with CloudWatch. So really the final characteristic of AWS to be aware of is this concept of load balancing and monitoring and how they all work together. All right, now that you know how the core architecture of AWS works and what the core services are, let's dive into the AWS Console. Really, this is where you're going to do all your work on AWS, and it's important to know how to navigate and get yourself around. I think the first thing to be aware of is if you look at this AWS Services tab here, you'll be able to look at every single service that's available on AWS. And it's vast, right? So you can see here it's divided by the different sections. So compute, we have EC2, Lambda, batch. And this is a great way to learn AWS, is just to play around, right? Is to click through these buttons, see what actually comes up. You can see here's containers, the things we talked about earlier, Elastic Container Registry, Elastic Kubernetes, storage, we have S3, EFS, databases, RDS, and so on. And again, my recommendation is you sign up for an account, use the free tier, and just start poking around and playing through these different services. That's one of the best ways to get started. So let's go ahead and do that. Let's go through and pick each one of these things here and learn about those in a very quick manner. So Lambda is one of my favorites. So I'm going to click on Lambda and let's go ahead and play with that. So to get started here, I can just click create function, and we're going to say author from scratch, and I'm going to say Marco Polo, and we'll say 2021. And let's go through here and choose Python. Let's choose Python 3.8, and I'm going to say create function. So really easy to get started in programming on AWS. And this, in fact, is one of the best ways to do it. Maybe the first thing, arguably, that you could play with would be building an AWS Lambda function. Now, I'm going to go through here and look at this piece of code. Even if you're not an expert in Python, it's somewhat intuitive. And what I'm going to do here is delete everything. And let me just tell you a few things about Lambda. First, this is really the core thing to be aware of, is that there must be a function that accepts things. And what you're going to accept is an event. And this is really where all the logic occurs, is you're going to do something with this event. And then you're going to either process it and or return some data. Now, in my case, I'm going to make something a little bit simpler even than their example. I'm going to say if the event itself, and we'll call that event name, if it equals the word Marco, then return back the word Polo. Otherwise, what I want to happen is that if it doesn't catch this event, then it'll return back no, right? So really a very simple piece of logic here. So I'm going to go ahead and I'm going to deploy this. There we go. And then next up, what I will do is that I can actually go ahead and test this. Let's go ahead and say test, and it gives me this test interface. And we'll call this first test here Marco. And remember that I need to have the word name in here like this. And we'll say Marco. And then I'm going to go ahead and invoke it. And notice what the result is. It says, yep, it returned back Polo. If I wanted to do the negative test here, and we'll call this Bob, and we put in the word Bob, it's going to return back no. So really easy to get started playing around with AWS here. And again, my opinion is to go through and start poking around the services. So that's compute. Let's go ahead and find another service that's fun to play around with. Let's go ahead and do a search this time. And let me show you the search bar. If I type in S3, it'll go through and it'll find S3. And this is the data lake, or the cloud storage that can hold petabytes of data. And in a nutshell, one of the things that you can do here is you can have buckets of data. So here's a bucket I created in the past here, and you can see there's a bunch of folders in there, and I can store CSV files or store whatever it is that I want. Let me just quickly show you what you can do. Here's a file that I uploaded I think, let's say about a year ago. If I go through here and I say actions, I can now download that file, right? And this will allow me to put this on a machine. Later, if I want to upload something, I can do the same thing. I can say add files, and here we go. Here's that data. It goes through and it allows me to upload. So you can almost think of it as a cloud storage system like Dropbox or Google Drive, but it's a little more low level, and you can actually control this programmatically, which we'll get into in a second. Now, now that we've done a quick overview of the AWS infrastructure, let me show you something that can really be helpful, which is the AWS Cloud Shell. The AWS Cloud Shell is a cloud on demand, and what this does is allows you to, without provisioning anything, to start kind of playing around more programmatically or from a higher level by using a terminal. And so in this particular example, what we're going to do is we're going to spin up a Cloud Shell, and we'll run a couple commands that will allow us to interrogate the AWS ecosystem. So in addition to playing around with services like AWS Lambda or AWS S3, the AWS Cloud Shell itself is a great way to learn how to use AWS, because you can use command line tools to interrupt with the storage, or interrupt with a service, or maybe query something, or talk to an API. So let's go ahead and wait for this to run. All right, now that we've got this Cloud Shell available, what can we do with it? Well, notice here that it says you can run AWS Help. That's a great way to learn some of the commands. Or if you know the command yourself, you can go through here and run your own commands. So this is a good way to learn things in the cloud, is to look at a command line tool, look at the help messages. But let's actually go through and look at AWS S3. So how do I do this? I type in AWS S3 LS. What does this command do? It'll go through and it'll list every single bucket that I have in my account. So you can see here how you can easily start to build up interactions with other tools. If I wanted to copy data, I could say, AWS S3 copy. In a nutshell, from a very high level, this is a great way to learn the AWS cloud. So let's kind of wrap things up here with one final experiment to tell you about. Is if you're into doing things on data science, one thing to take a look at would be SageMaker. If you're into doing development, one thing to look at would be Cloud9. So what we're going to do is we're going to wrap things up here by talking to a Cloud9 instance, and I'm going to show you how you can develop applications using a cloud-based development environment. So let's go ahead and do that. We'll say create environment, and we'll say AWS Playground, and we'll call this the playground for my code. And we'll go ahead and say next step. Now, if you're a student or you're just playing around here, I think this is a great option. The defaults use a micro. You don't have to pay for it if you fit within the free tier eligibility, which is basically a certain amount of hours per month. And I would leave everything default. You could notice here this says Amazon Linux 2. I would recommend that. You could choose into Ubuntu if you want to use a different operating system if you're an advanced user. And the other thing to be aware of is that automatically you have these cost savings set up for you so that after 30 minutes, it'll hibernate and you won't have to pay for it. So it's really a great default practice where you can just click a button, start this up, and if you don't change anything, you'll have a great experience. So let's go ahead and create this environment. Okay, so we've got this AWS environment spun up here, and notice that it's a really interesting environment in that it has both an IDE where you can develop Python code, and let's go ahead and start with that. I'm going to say touch hello.py here and make a piece of Python code, and I'm going to put in a hello world application. Let's go ahead and say prints hello, and if I save this and then I say Python hello, right, you can see I can immediately start developing code. Beyond that though, I can do the same thing I did earlier. I can say AWS S3 LS, and I can look at my buckets or run whatever command I want to run. I can also go over to this outline here and look at the different components of AWS. So I could, for example, talk to other people and let them, use my team, or I could actually go set up a debugger. There's lots of new capabilities that you can actually experiment with Cloud9. So In addition, I could go through here and let's say if I wanted to run Docker, right? I could run Docker commands, build Docker containers. So if you're a developer, this is probably the place you want to start to play around with because you can develop code locally. And notice here this AWS tab. In addition to that, what I can do is I can actually play around with S3. I can also build Lambda functions, I can do CloudFormation, and I can do API Gateway. So it's really the one-stop shop for a developer on AWS.